Hello there. I feel like I've somehow conditioned myself to, whenever I hit play or hit start streaming, I immediately, somehow, this is weird, I both have to pee and get super thirsty. I don't know why. I don't know if it's because my body's like, oh no, you're gonna stream. And whenever you stream, you don't pee for a long time and you forget to drink water. So I don't know. I don't know. Hi there. We're gonna, I'm like fighting 3D print battles here. Is the video fuzzy? Why is the video fuzzy? This print, I was trying something insane. I was trying, helping out with a project, and things aren't looking so good with the project, and they need to cut down some time on some production, and so I was like, well, let's try to 3D print this thing with 4% infill, meaning the internal structure. And it actually was fine, and had this been a cube, it would have been fine, but it has to have, like, it goes curvy, and the 10% infill was definitely not enough to support it. I feel pretty confident that there was some kind of infill that was the right kind of infill to use, but I just don't know how to, like, yeah, I don't know. Some kind of infill that would transition or something. I don't know. I don't know much about getting real fancy with the infill. Anyway, we're not talking about infill today. We are gonna add a screen to that center for no real reason. Just because we can. Kyle, how's it going? So we did this thing, right? Where we made our cute little... Did I save that? I hope I saved that. Okay, first, hold your horses, first of all. We have to pick the wallpaper, first of all, before we even think about the task of the day. By the way, how are you? And then let's switch over here. We can't get ahead of ourselves. We got kind of like this wallpaper. Should we just go with this? This never happens. We're just gonna pick the first wallpaper. Okay, we have this thing, and we, for some reason, processing does not show up in the start menu for reasons that nobody really understands. Maybe I pushed the button that says "Don't show up in the start menu." Who can say? Forget it. Okay, wait. I have to switch here for 1 second. Switch here. Switch here. Wait, here? Here? Push this button? Does that work? I don't know. Maybe it worked. Where did I put this stuff? I think it's in here. Okay, we can switch back. The secrets are gone, maybe. Here? 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 Okay, we found it. I don't know why we can't find processing from the start menu. Okay, yeah, so we just made this simple, very silly, simple visualizer. And then, you know, as is his purpose in life, life is yours. I don't even think he said it. I think it was just his presence convinced me that I needed to... Port 7 busy, huh? That's no good. So we need to attach a screen to this thing. Because... Sure we do. Right? What port are we on? COM7. What's wrong, COM7? I don't know what would be talking to COM7. COM7 port not bound. But I just saw it. We just saw it in Arduino. So... So I don't get it. Like, we look in ports. No, there isn't. There's only the weird pretend port. So where's COM7? I ask you. COM7. Okay, COM7. COM7. Go. COM7. COM7 port busy. And now when we look back here, is COM7 going to be broken? What is going on, everybody? Why would COM7 be busy? Okay, let's try this. Can we see, does this work? No, COM7 busy. What could possibly be using COM7? What? What would be talking to that port? What? Okay, I'm gonna plug this. I'll plug this in here. COM something else. Okay, bunch of great raw data. I don't know. And there it is. Okay, so here's our cool depth image in beautiful 64 beautiful pixels. And the order of the day is to try to connect a display to that, but I've lost the display, so work is canceled. I found the display. It's in this box. So this box has a very distinctive kind of electronic smell. Very, very electronic. Okay, we're trying 10% infill now. We'll just hope that works. Okay, we have this. It has headers. We have to figure out how to talk to these things. And I don't really know how. I know that we need that one Adafruit whatever library. So we're going to use our teensy thing again. So I don't know. Let's just figure it out. So it's Adafruit whatever. This thing. So I think there's two libraries we need. So we need the graphics library and the IL9341 library. So here's the problem though. If we use, do we have to use our new teensy friend? This thing to add that to our project? Maybe? Probably. This lost all the settings. Can we open project? Okay, that seems like it worked. Okay, from libraries, we need Adafruit, Gifix, and Adafruit Illy. The other teensy Arduino libraries installed. I have neither of them. Arduino repository shows nothing. Maybe I had to push the button. Okay. Gifix and Illy. So that's the Adafruit Gifix. Right? And Illy. $93.41. So we add one of those And now, can we just save it and everything's happy? Unhandled exception. Is it because we have Visual Studio open? The crash Visual Teensy? Open project. Weird PLA fumes in here. It's estimating 17 hours. That's not good. Not promising. Okay. We opened this. I loaded the thing. It says those libraries are there. So presumably we can use them. One issue is I didn't really... Oh my gosh. I did it perfectly where I do actually have a little bit of room for this. I guess it doesn't really matter. Kind of a mess. I should just move this whole thing over. But I don't want to... Okay, where's the hand cam? It's not currently in service. Look at the hand cam and look at hands, and it's really great. Is this it? Hand cam? This is looking at my chin. Hello. Okay, so let's here and down here. I don't, we're still this whole hand cam thing. Experimental. So yeah, I just smacked this right in the middle of the board where it was really inconvenient, but I think I remember this. So we skip 2, then have these 2, skip 1, and then just basically, or in other words, it's more like ground, 3 powers, then orange and green. So let's just think of it that way. So ground, power. Ground, power. Then orange and green. Orange, then orange, then green. Or was it skip 1, then orange, then green? Oh no! We don't use the last 2. Okay, so that's that low power pin, so we don't actually care about it. So it is skip 1. Okay, so hopefully this still works. Doodaloo. Doom-doodaloo. Uh-oh. Why? What does it do? Doodaloo. Okay. Great. So that's fine. So I was just making a little room. Is this blurry? Is it in focus? There's an eyelash on my desk again. My desk always covered in eyelashes. I didn't move that over enough. Why didn't I just move it all the way? Who can say? Let's just move these over too. And And this one. And this one. I should have bent them all up so they don't cooperate. Doom to doom. Surely it should not do that while things are powered. Doom to doom. What are you talking about? It's not busy. It just isn't. Material's real something. Okay. That was an unnecessary diversion. So we'll just pop this in here, but here's the issue. I don't know any of these. What are we gonna do about this? I just want it to focus. Just focus. Be nice if I could get this to focus and then take a screenshot so I knew what it said. Can I do it? Okay, we did it. Incredible. Okay, so we got the thing. We've got all this stuff. This puts VCC at the bottom and ground at the bottom. So I think we just assume. I forgot if it's supposed to be 3.3 volts or 5 volts. Let's just assume it's 3.3. That's probably a safe assumption. Okay. So what did I say? Said pin 1 was VCC. Oh, it's right here on my screen, on my very own screen. Pin 1 VCC. Pin 2 ground. This is just positioned just perfectly to not work very well. I just shorted it. Oh no. Oh no. That doop-diddle-oo was me shorting this board. Not ideal. Is that okay? Okay, I'm gonna bump this down one. Try again. Just that punishing doop-diddle-oo. Okay, power. Some ground. I'm struggling with this time. Okay, power ground. CS reset. DCRS. SDI Mosey. LED. SDO MISO. So we care about MISO Mosey. I don't know if we care about the clock. I can't remember. We just got to go with the documentation, I guess. So the documentation says what? Because the Arduino wiring is not going to be right. Oh my gosh, Diraj, hello. You have a new account. Or is this like the sequel, Diraj Part 2? I'm doing okay. It's good to see you. I wish I could like right click you and give you a pony. And give you a helicopter. But I can only ban you or give you a timeout, so sorry. Okay, so we want to what? We don't care about MISO. So the clock. So these are the things we care about. You got your old account suspended. What happened? What happened? This is 5 volts. Do you really think we have to power it with 5 volts? I'm not gonna. So we just need to actually look these up, these pins for our current device, right? So I have this new little sensor. I'll show you. This adorable little sensor. That is my new like little distance range finding guy, but it's an 8x8 grid, so it's like a very tiny little depth camera. And we can do doodaloo. Why do you say COM port 7 is busy unless I unplug this end? If I unplug one end of the cable, it's fine. Twitch hates you. I'm sorry to hear that. Twitch hates everybody, I think, so I wouldn't take it personally. Yeah, so here's our depth image. That's my hand, very high resolution. And so we just want to hook up this display that I happen to have for actually kind of no reason. I have never hooked this to this particular kind of microcontroller, so we're just gonna figure it out. It is like the fumes in here. Whew, am I gonna die? PLA fumes aren't harmful, are they? It only says 5 hours remain, but I don't believe it. I think it's gonna take longer. Can you believe this? 5 hours. Focus. Focus. This autofocus is really incredible. Okay, never mind. So this sensor it's kind of a time of flight sensor. So I talked about this a little yesterday, but there's lots of ways to for a computer to know how far away something is, basically. So it can use ultrasonics with sound. It can send lasers. It can send like bounce IR everywhere and look at it with the camera and try to figure out what's going on. But this sends a laser and bounce it back, but it's like an array. So instead of just sending one laser and bouncing back, it sends out an array of lasers and they bounce back, and I get kind of a tiny little image. Wait, life is yours, but you don't want it to... Wait, hang on. Don't you want it to flush when you stand up? You want to flush the toilet while you're actually actively using the toilet? Because that doesn't seem good. It doesn't seem like the way to do this. Okay, what are the pins that we need to use here? Because I don't know. Like, how do we... So like clock. So cable select 0, cable select 0, cable select 0. How do we have 3 CS zeros? There's some over here too. And MISO 0 and MOSI 0. Why would there be so many CS zeros? I mean, I guess, does it matter? And there's clock. There's SCK 0. Wait, say what again? About the toilet? I don't want to talk about the toilet anymore. That's life is yours. It is going to transition from being an electrician into being a plumber, apparently. Oh, you could be a hybrid electrician plumber and specialize in both. Oh yeah, so the sensor. So there's 64 pixels on the screen, right? And what you're seeing is a bunch of distances. So red means really close. So when my finger's right over, it's red. But as my hand moves away, it kind of shifts through here to orange. The blue is the ceiling, so the blue is especially far away. There's my head. So it's like a very low res depth camera, but it only costs $10. So it's like a really cheap. So they're used for a lot of things. They're used for like, there's lots of proximity sensing applications. Something that's this fancy might be used for like a drone or a robot, like a robot vacuum or something. No, so what you need to figure out is this, because here's the brilliant thing. People go through all the trouble to run wire through their house and run plumbing pipe through their house. But imagine if you just sent the electricity through the water, you'd only need one conduit. You could have a single conduit that had water and electricity, and you'd save so much time and money. So I wrote the Teensy code, the code that's running on the Teensy right now. I mean, it uses their library, and in fact, it's their library wrapped by a library from SparkFun. So my job was not that hard. But here is our current source code is just this. It's very short, and most of the work was writing this is the code that sends the data from the Teensy to the computer. And then this is the data that draws it on the computer. So it's not very much code because most of the work is done by their API layer. So I don't know what pins to use. I just got a like SPI on a Teensy, huh? Like, how do you a faster SPI library? I don't think we care. Okay, SS, SCK, Mosi Miso. So we'll just use these pins. So, if I just say SS, SCK, Mosi, and Miso. But what is SS? Is that the same as CS? Because basically we need these four things, right? I don't understand. So we need we need to be able to select, we need a clock, and we need data in and out. So data in and out is easy. That's the clock. So actually don't even need data in. We really just need data clock. I don't think we have one of those. So is CS the same as SS, select device? I think it is. An Arduino Uno is maybe $25, $25 US. There's tons of clones. So an Arduino Uno, for example, from Amazon is probably like 20 or 25 bucks. So it's $20 on sale. But there's a million clones of them. So if you thought that was too expensive, you could just get some clone. Like here's a clone for $15. I have had mixed results with the clones, but I like Teensies now instead of Arduinos. But I just have to translate these pins. Like the data clock, does that matter? I don't know if it matters. I don't know if it matters. We're just going to go through and figure out what we have. So we have CS, which is the cable select or chip select. So we'll connect that to select device. So we'll connect that to pin 10, I guess. Okay, so that is the next pin, and that's going to go to pin 10 on the Teensy 3.5, which is ground 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe? Okay, I'm going to hook this. Yeah, I think it is probably worth, if you, for your very first one, just so you don't have to figure out anything weird and there's not like weird whatever nonsense because of a clone or something weird. I think it is actually best to just start with a real Arduino Uno R3, because that's going to be most tutorials are going to be about that, and so I would say that is the safe place to start. So we don't care about reset. DC. What is DC? Data clock. I don't understand why there's 4 pins that we need. Just because there already is a clock. Like, what? I don't know. And then, okay. 3, 4, 5. The 6th pin is MOSI. Well, which one did it tell us to skip? So we want MOSI. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 6 is the MOSI pin. And MOSI is pin 11. So that's pin 10, pin 11. So that was our cable select and our MOSI. And then we need the clock, which will be pin 13. So MOSI and then the clock. Would that come right after that? SCK, clock. Where did I say that was? Wait, I feel like I did something wrong. 10, 11, 12. Clock is pin 13 on a TNC. That's the LED pin. Weird. Okay. Ground is the pin that's right next to the... So I think that is the clock. And then LED is just power, right? Like that's just hook it to power, you think? Like what are the pins here? I still don't know what this is. DC, I just don't know what that even means. I'm gonna ignore it for right this minute. But what about the LED? That's the LED backlight, right? I've definitely wired one of these up before. How did you do on your exam? How am I doing on this exam? I think I'm failing. LED is the second to last pin. I think that's just the backlight, and I think we just power that. I kind of would have thought that the power would turn on, but it didn't. Does it need 5 volts? Oh, it's not plugged in. You gotta plug it in. So the backlight didn't turn on. If I do this, will the backlight turn on? Oh, that was the wrong pin. Oops, don't do that. I may have just fried this board. I don't think so. I think it's 5 volts all right. Backlight? Oh, look at that backlight. Incredible. It doesn't look very healthy. Oof. You think it wants 5 volts? It doesn't. Okay. I don't. A good old-fashioned struggle break, right? Okay, so this is like a, I don't know if it comes from the video. It's like an epilepsy hazard at the moment. I don't know why that is. It's this pin. I mean, it could be that because we have some floating pins. Who knows? Who knows? Could be because this has been thrown in a box for years. Who can say? Who can really say? Okay, I just totally skipped the data clock pin. Maybe somebody has hooked up this particular one. That's the out of rear line. That's what we just looked at. So this is what I have. It says you need resistors, but there's a bunch of resistors on this board already. Right? It's probably fine. Right? Right? It's a bunch of resistors. Should I wire this through resistors? Am I in trouble for not wiring this through resistors? There's resistors right here on this board. Look at all these resistors. This board's covered in resistors. Yeah, look at that. Okay, what are we trying to do here? I don't think I've done this correctly because I didn't even hook up all the wires, but let's skip that for just a minute. Oh, we should just do this. Are you going to be an Arduino hacker? We should just make this easier on ourselves. We should just do... I mean, you know it's my general approach to fix every problem with WebSockets. For me, WebSockets is the hammer and the world is the nail. And that's just how I go through life. No, was it ULI? There's really no reason to do what I'm doing except I just have this screen. And I thought, hey, that's probably a thing we can make work. What is it? What is it? It was ILI. I was right the first time, wrong the second time. I don't think I want those. Do I need these other things? Do I need that? I'm going to say no and see what happens. And we'll see if things go really badly. Okay, so here's the thing. It's getting so warm in here from that printer. So we want graphics test, right? Let's just upload this and see what happens. Okay, DC and CS are just whatever. So DC is 9. So DC needs to be hooked to 9. CS we already have as 10, right? SS10. Okay. So 9 will be DC. So which pin was that? DC. So it was, that's 1, 2, 3, 4, 5, pin 5. 1, 2, 3, 4, 5. And I said I was going to plug that into pin 9. Did that actually upload? No. You do 3D graphics on this tiny screen? Life is Yours was running Doom on his, weren't you? Yours was even a smaller screen, right? Okay, this appears to be going great. Appears to be going very well. So it looks like we uploaded. No, access is denied. Do this thing instead. Okay. Display power mode. This, we appear to not be doing well. 4 or 5 pins required to interface. RST is optional. TFTCS DC. If using the breakout, change the pins as desired. I mean, it kind of seems like we're not. DC. CS we hooked to the thing that's at SS. Pin 10. Our voltage could be too low. Wait, I just jiggled the cable and it looked better. It could also be that this breadboard is awful. It could also be that I should stick a capacitor across power and ground to stabilize things. If you lived in my home and you were a capacitor, where would you be? These all look like capacitors. This is a pro electronics tip. I hope you're all taking notes. If your circuit is bad and jiggly, just stick a capacitor across power and ground and hope that it stabilizes a little bit. That's true, actually. That's a good point, Binary. There's probably capacitors in everything in this room, and I could just borrow one. Wow, look at that. It worked. I mean, it didn't actually work, but it stabilized things a little bit. That's my graduate degree in action. That's one of the 4 things I learned in grad school. It almost seems like something's talking to it. Here's the things I learned about circuits in grad school. You ready? Just stick capacitors all over the place. Just across power and ground. Just stick them everywhere. That's rule number 1. Rule number 2 is if you kind of need to cheat voltage down a little bit, just stick a diode in there. Just stick a diode in there and it'll be fine. Like, for example, if you have something that's supposed to run on 3 AA batteries, which would be 4.5 volts, and you're trying to power it with USB, which is 5 volts, you just want to kick it down a notch, just run that 5 volts through a diode, and then you'll have 4.3, which is probably close enough. How are we doing over here? And also his rule is always touch the ends of the capacitors together. Or maybe don't. This says we have 5 minutes left, which I don't think is correct. Because now it says there's 99 minutes left. So who do I trust? Camera's really does very well with all of this. Shouldn't touch anything. So it says it went from 5 minutes to 100 hours. I tried some stuff maybe I shouldn't have tried. I like pretty dramatically cranked up the infill speeds, and that might have been a poor choice. Too late now. Okay, what are we doing? It like briefly seemed like it was doing something, right? Like there was a moment where it sort of looked like it was doing something. I think that was an illusion. Okay, let's do the boring thing and check all the connections because I probably did it wrong. Okay, VCC. So right off the bat, I don't actually know if this thing runs at 5 volts. I kind of think it does. I'm sorry, at 3.3 volts. VCC power voltage 3.3 volts to 5 volts. Logic is 3.3. But what is the backlight power? Doesn't say. Okay, but anyway, so we feel okay about that. So let's just go through the pins, I guess. Pin 1, VCC. That is definitely plugged into power. It's not plugged into power very well. Let's plug this in over here. This is not a good breadboard. Yeah, so this is weird. The fact that the clock pin is the LED pin. I can see the LED pin pulsing because it's a clock. That's weird to me because it's my instinct to like never it's my instinct to just consider the LED pin on a microcontroller just forbidden. Just don't touch it. Don't ever use pin 13. It's unlucky. Display power mode, pixel format. So I don't think we're actually talking to this thing. So yeah, I guess we just need to go through the pins. Okay, pin 1 looks like it goes to power. Pin 2 looks like it goes to ground. Pin 3, which is cable select, I just plugged into pin 10. I think. I think that's pin 10. Ground 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that's right. Pin 11 is the reset pin. Oh, I'm sorry, the next pin is reset pin. We did not use reset. We used DCRS. And that we plugged into according to the graphics test. to pin 9. So that's one pin north of pin 10. So let's assume that's okay. Next is SDI/Mosey. Mosey is pin 11, so that should just be on the other side of pin 10, presumably. Pin 11. That seems correct-ish. SDI Mosey. That's the data output. That's pin 11. And that says Mosey. Next is SCK. So S clock. That's the one that's pin 13. That kind of weirds me out because that is the LED pin, but that looks like it's S clock. Pin 13. And that says use pin 13. And then next is the LED pin, which I currently just have plugged into power because that seems like the thing. And we didn't plug in MISO, but maybe it actually does have to have MISO plugged in to get this data from the screen if they're going to talk to each other. So let's just try it, which is pin 12. So this would go here. Sure doesn't look good when it's so blinky. I was using the screen last year with the Raspberry Pi, and it seemed like it worked at the time. I mean, we got numbers this time, but they were just F, 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 so... What are we doing wrong here? What do we think the problem is? I mean, it could be that some other pin here is not the right pin. You know? So let's just be thorough and just say you think so, but let's just... So reset's optional, right? Reset's just whatever we decide is reset. Okay, so we said... this is the only one of these that I have. It was working not that long ago. I guess it's possible that I murdered it at some point. Okay, Mosey. 11. I mean, we could also hook this up to an Arduino and just make sure that it's not a teensy thing. Clock. 13. Reset. I guess let's just make pin 8. And MISO is pin 12. Oh my gosh, it's Draklin. Yeah, this is the display test that comes, I mean, it's graphics test that's for the Adafruit library. 4 or 5 pins required. Draklin, how are you? You're just in time to see this. You're just in time to see this. Welcome. Where was the reset pin is the one we ignored. Look how unstable the power is. I don't know if that's the breadboard or... The clock seems very slow. Look at that! I have graphics. Wow! It was all worth it. Look at these incredible graphics that you can't see because they're out of focus. Incredible graphics. Dead beef. Dead beef. Dead beef. Root. I implore thee. Actually impressed at the text legibility. So we're just doing a fun little loop-de-doo. Okay, well I'm overwhelmed right now because we got the screen to work and Draclin appeared. Draclin, who is, you know, obviously the... I don't even know, the founder of this channel, basically. Even I come second. This channel should be called Draclin Made This because this channel is built upon the back of Draclin. So let's do two things. Let's check the print. The print currently says 98 hours, which is not good. Okay, this works. So we just need to figure out how to draw, right? I don't actually know what fixed it. I don't know if it was hooking up the reset pin or if it was me manually specifying all the pins to match what we know that the Teensy wanted, or just me jiggling the cables, because very clearly this, I guess it's the breadboard, and now it's dead again. And now it works again. So if I unpower the backlight and then repower the backlight, it's just so not good. Is there a 3.3 volt power supply on this side? There is. So it's the third pin down. So let's try this. $250 milliamps max. Maybe that was a bad idea. Oh wait. You have to do this. Why is it so jiggly? What is wrong with this? Is it this cable? Maybe it's this cable. Draclin, it's an accessibility feature so that it can be legible to anyone, you know, whether regardless of their personal physical orientation in space. Let's try another red cable. Maybe that red cable is just cursed. Oh, look at this red cable. Rock solid. Rock solid. Nice of you would just stay focused on that. Doesn't want to. Draclin, what is going on? Are you taking a break from New World? Are you still playing New World? Are you still loving New World? Did you pick out your house yet? I've been house shopping because yesterday I got rich, and so obviously I need to house shop. Did you move? You moved? How did it go? I can't believe this. Draclin lives in California, like a movie star. You live in the OC? I'm actually getting maybe like slightly faint. Is PLA fumes toxic? I don't think they are. PLA is less toxic when it comes to others, when it comes to creating toxic fumes. TLA comes out on top in terms of emission of toxic fumes. Wait, is that good or bad? Microfine particles. Okay. Oh, that's smart. Right. If you reside in the virtual world, it's much easier to move in the physical world. Okay, I need a short break. I'm gonna go to the bathroom. I'm gonna drink some water, and I want to know what's going on in the OC. Be right back. I think we're almost to the point where my previous print failed catastrophically, so that's good news. Okay, so hi. Hello. What do we do now? So the whole point of this was to just draw our squares, right? So now we have to learn how to do this thing. Okay, yeah, we got data back from the thing, so that's good. Screen fill in microseconds. Text lines. So I have been working on some projects. One of them is this musical chair that we'll look at again soon. And another one is this thing where it's going to be a wall of frames. And as you approach the frames, they'll like slightly animate. And they'll animate based on proximity. And it's so simple, and it's such a simple idea. But somehow I have spent like $150 between $150 and $200 on buying sensors to try different sensors for getting good proximity that I'm happy with in like a gallery kind of setting. So there's a wall, there's frames on the wall, there are screens, they respond to you as you get close to them. It's going to be a pretty simple thing. So I've drastically overthought the hardware. Tried ultrasonic, tried like low-end time of flight sensors, tried fairly nice, like single point LiDAR, to tried a rotating LiDAR sensor, and then this thing just came out. So this thing is basically an 8x8 time of flight sensor that's pretty good up to 4 meters. So you get a little low res display basically of depth. And so I had written a little processing sketch to visualize that. And then I blame Life is Yours. It's obviously Life is Yours' fault. I thought like, well, I should just, obviously the thing to do here is connect it to a dumb little screen. I mean, right? What else would you do? So I don't know how to use this, but it looks easy. Like you just say you want to fill a rect, and then you want to draw the rect. Or I don't know. What are all these parameters? Why would you need this many parameters to fill a rectangle? I mean, I could do, well, I mean, you know, I could talk to via serial to the Pi. But I wanted to just try to hook the teensy to this because why not, right? But why does this, fill rect doesn't need this for any parameters, right? Well, this thing is going to talk, I think, to 6 Pis simultaneously over its 6 serial ports because it has 6 serial ports or 5 serial ports. We've got cereal, we've got pie, we've got other things that sound like food names that I can't think of right now. Like, I don't know. I don't actually, it's actually just those two. I thought I would be able to come up with another one. Yeah, that's the rect, but this is the fill. So why does the fill? Oh, that's to draw a filled rectangle. I see. We got some Ada fruit. It's true. We've got some group. We've got some dead beef on the screen. So, okay, I see. This is a combination of fill and rect. Both of those at once. I get it. Okay. I mean, can you use them separately? I mean, I don't mind necessarily. So what do we actually need here? Is all we actually need is this and this and this? We didn't include SPI. What if you weren't blurry, other camera? What if you just decided not to be blurry? What if I manually focused you? Great. Nailed it. Okay, how about that? Looks pretty good. Okay, so we need to do what? We need to steal this whole thing. We have to run Visual Teensy again to add the SPI library. So that's a Teensy Arduino library. We want SPI. We want the slow one. We want to save this. Kind of like this thing, sort of. It's a little weird. It just crashed again. But it's convenient when it's crashed. Maybe it didn't crash. It just moved backwards. Maybe that's all that happened. Okay, so so you're telling me I can just cram this up here and everything's magically going to work? Is that what you're telling me? Look at how it alphabetized my includes. So fancy. Squiggles are disabled for this translation unit. It's right here. Maybe it crashed while it was doing the thing. Come on, Visual Teensy. I mean, you know, I like it in theory. I don't like that it crashes. But when it doesn't crash, I like it. So these are our libraries. We have these. We'll do a file save. Oh, it freaks out when you're... Okay, are we okay? Like, where's... Why didn't it actually copy over this library? And this file is right here, so why is it unable to find this file? Is this broken? This kind of looks broken. Maybe this is broken. Maybe we need to try that again. From Arduino repository. VFX. Okay, that put a bunch of stuff in here, but it still weirdly seems like it can't find it. Or maybe that's just the editor being a dummy. That didn't look good. Adafruit I2C device. I don't want an I2C device. In file included from Adafruit GFX library, Adafruit Gray OLED, Adafruit I2C device.h. Why would that be? Why would that even be a thing? Not for a tiny at all. Is this supposed to be inside here? Maybe that didn't. We didn't install it. We didn't have those other. But why would that even be included? Why? Who's including that? I wonder if this is a dumb thing with this build setup where it's just going to try to build every CPP file. I bet it does. Right? Like that's probably just the thing that happens here. Is it just finds every C++ file? Does that seem like a thing it might do? I don't really know how makefiles work. Oh, yeah, it's so fancy. I don't want it to be fancy. Yeah, it just looks for all the CPP files. Well, I don't want it to do that. I mean, I get it. I think they just did that. Yeah, recursively create a list. Well, that really kind of isn't great. Target ID visual code. I mean, I could just delete them, I guess. Because I don't want them. This doesn't feel very good when I'm doing it. Because I don't want to spend time fussing with this. Uh-oh. Wait, did I delete a file that I wasn't supposed to delete? I guess I wasn't supposed to delete that other file. Oops. Oops. Oopsie. Okay. Well. Shoot. It seems like, okay, we just fully broke it now. Great. Very good. This is not, uh-oh. We have multiple visual teensy windows? Are these now out of sync? Uh-oh. So that has everything. Okay, now let's go in here. Let's only delete this thing. Yeah, that's not a good feeling, but what are you gonna do? Did it work? We uploaded, but it's still drawing graphics, so why would that be true? Oh, we didn't upload. We just built. What? What happened? Teensy Loader could not find the file Lone Ranger. What? I feel like this was working really well yesterday, and then today it's really cramping my style. Could not find the file Lone Ranger. What? What are you talking about? This worked so well yesterday. And today, it's just making me mad. Anybody? What did I do? Let's clean and try again. Process can access the file because it's being used by another process. Is it you, Teensy? Is it you? I mean, okay, the cleaning done. Maybe just it was some kind of access violation. I don't know why. Now can you upload? So you build first. So the build seemed like it worked. The build seemed like it was okay. It was just the actual upload. But it was not very clear about what the problem was. Yeah, so what is it? What? Could not find the file Lone Ranger. So that is the that's the hex file. LoneRanger.hex is the file. Upload. So the like those look correct. Oh, was Teensy getting mad? Lone Ranger hex unreadable. Doesn't seem good. Do I still have the serial port open in Arduino maybe? I'll explain why I wouldn't see the file. So the build writes to this hex file, and it looks like there's hex in here, right? And then the make command, presumably, Teensy loader. Huh? Teensy loader. Wait, but that's not what we're using. Aren't we using PJRC? The upload run, so that's a task, right? So when we call upload, it just runs make with these arguments. So it's make that is actually calling, which I don't like. I like the whole make part of this kind of lame. I get why they do it, but it just adds so much bloat. Like make just adds so much nonsense. Not a fan. Okay, let's close. Yeah, I don't know. I don't even see where it actually calls it though, which was annoying. So like in the make file, upload. Like I don't understand why it says teensy loader though, because we're using the PJRC uploader, aren't we? Yeah, upload all is supposed to be upload PJRC. And upload PJRC is just this. So here's the command. So file equals target name. So yeah, maybe the target name's messed up. Okay, I'll try to clean again. I'll try to build. And these seem like the things, right? I mean, maybe something got wrong. Something got wrong. Something got messed up when I generated the thing. Okay, I think I just needed to restart the little goofball teensy app. Okay, so we're back to Nightmare's Flicker, which I think is just noise because we're not actually drawing anything. So now, what? We want to just do that TFT fill. What was it? Can't believe Draclin lives in Orange County now. That's part of our balanced breakfast. Man, that's killing me. Okay, so that was, you know. This is the worst way to navigate through examples. What a terrible design. The graphics library. Graphics test. This is what we were running. So, like, just fill, for example, if we wanted to make it red. Wasn't there a background? Or just this fill screen, fill it black. So, just in our loop, we just blank the screen every frame. Is it gonna work? I don't know. Oh my gosh! Life is yours. Are you gonna visit Draclin and go to Disneyland? Please do. Life is yours. When is your grand tour of the U.S.? What did I forget? of the US West Coast. Okay, we probably need to do this, right? That seems like a thing we're probably supposed to do. I don't know why this happens, where the Teensy will get into this state where you have to push the button up top. There's so much about the Teensy that is so good, but the like programming process is just not quite there. Okay, we made the screen black. It is still flickering though. So what happened? I thought it was happy when we plugged in our new cable. I thought the new cable would solve all my problems. Should I not have the backlight plugged into that? Maybe the backlight should be plugged into... I wonder how much current that light takes. It can't be that much though. And the fact that it will stabilize if the cable is... I don't know. Do I just blame this on terrible breadboards? Or is there a deeper problem here? Forgive them for what they did to Star Wars. Star Wars was ruined 20 years ago. 22 years ago? Okay. I'm going to be honest. What's going on over there doesn't look great. It looks better than this. It's an improvement over this, but still... maybe questionable. I think I'm gonna let it go. Yeah, I'm printing this. Ugh, it's a monstrous thing, and I tried to like optimize the model to get it down from like a day and a half print to maybe a 10 or 12 hour print, but I may have over optimized. In fact, I'm pretty sure I over optimized, but I don't know. Now I'm like an hour in, so do I try it again? I don't know. Okay, why is this so bad? And why does it seem like the capacitor is no longer doing the magic trick of making everything good? Okay, how about that? Blame the software for the screen flicker. It's still there. I mean, it could be these incredibly cheap jumper cables that I just have spaghetti of, or it could be the terrible breadboard, or it could be this incredibly cheap board that I got on eBay or something, maybe from Amazon, years ago. Okay, but I feel like in general we got it, right? So let's figure out how to draw a rect. I'm kind of impressed with the text, I gotta say. So this, we want to draw a filled rectangle. So we assuming this is coordinates and then a width and a height and a color, right? Do you think we know the width? Yeah, 250 width. Okay. So you're telling me down here this is pretty silly. Okay, I'm gonna ignore how silly this is for a minute, and we'll talk about why it's silly in a minute. But for now, let's just do this, and then EFT width divided by 8. Now wait, we have an actual variable for this, right? Is that our width? Our width? I think we are tracking that. Okay, then what is a color? Like, encode. No, I didn't buy a house because Unity crashed, but then it went up again today. So maybe I should buy a house. I'm probably really not going to buy a house until summertime, next summertime, when my lease is up here, and I will have owned Unity for more than a year, so I can pay long-term capital gains instead of short-term capital gains. I don't have a great deal of faith with what's going on over there. Like actual, oh, just straight up real deal, just 32-bit. Wait, but it says it's a UN16. And that's 24 bits, right? Wait, where was that? Is that? Are you telling me the truth? This is a 16-bit color, and that's hex colors are 32-bit. What am I missing? Because we could actually look at documentation, right? Heaven forbid, but let's do it. No. Hex is not. Well, that you just wrote an 8-bit value. I'm sorry, byte. 8. That Wait. That was 3. Two, 4. That was 6 bytes, right? You just wrote 6 bytes? If they're separate? I'm confused. This is it's 16 bits. No, this is 8 bits. Right? A hex value up to FF is 8 bits, right? Yeah, I should just use a const. Diraj, hello again. And so when you have 3 of these, this is a 24-bit number. Right? Right? We're very close, Diraj. It is we made the screen black. Yeah, but it's not, I don't think it's the same as a hex value in HTML is 3 8-bit values just, next to each other. But this specifically says a UN16. So what's the truth? What's the truth? So this is a little different. Like the Adafruit one seems different. So we need the graphics library. Like, what are their constants? The constants are hex values? Okay. So their colors are goofy. So they have 5 R's, 6 greens. So this is not the same as... That's true. I could just click to the constants. So this is not the same as... Yeah, so this is... It's 16 bits, but it's not 8 bits per channel. It's 5 bits of red. 5 bits of red, 6 bits of green, and 5 bits of blue. Which is pretty weird, if you ask me. But, okay. That sucks, because I want to do hue operations. It doesn't. HSB? No. Man. Is there some method to make a color for you? I don't like that. What? Alpha has nothing to do with this. This is literally says there's only 5 bits of red, 6 bits of green, 5 bits of blue. There's no alpha here. If I had alpha here, it would be 32 bits. It takes 32 bits to have alpha. Normal hex colors, if you're thinking in HTML, are usually 24-bit values, where it's 8 bits for 3 channels. They are packing that into 16 bits total, which is fine. It just makes things a little weird, and it's annoying that there's no hue. So if they're just like, do they have something where they're looping through colors? Like, what are they doing? Okay, well, let's just start and make sure we can draw a thing, and then we'll figure out, because it's kind of a bummer. Like, I should be clear. I don't think it's Adafruit. That may just be what this device, supports. Like, that's just what you have to do. Well, it's not. I think this is very specifically, this screen only takes 16-bit color values. And so if you want to cram a red, green, and blue channel into 16 bits, things get a little weird. In most other contexts, which is not unusual. Like if you have to, if you have 3 things to divide among 16, you're going to have 1 extra. And the human eye loves to see green, right? So this looks very bad. Why do you think that is? Do you have to so we called TFT begin. There's something we're supposed to do in here? Set rotation, test text. So we fill the screen. I mean, that does take a little time, I guess. So maybe the thing to do... Well, yeah. Oh, right. Oh, this is going to be terrible. Okay. Okay. Oh, this thing's really slow. Remember? It's like 15 hertz. I mean, it's going to take time no matter what to just process whatever comes in. And then this is us both like getting the ranging data, whatever. It's fine as long as we just have to draw, like, we just couldn't split it like I had it. That was not the way to do it. It meant that there was a gap of time between when we drew the screen black. Yeah, I have to manually clear it. It's just I cleared it and then did work, and then drew the square, which is not right. It's not the thing to do. I don't really understand this. Why would this be true? So is the thing that I just said not actually true? Kind of bummed out about the like, how could we do this? Like, we could just do it. We'd count up from blue, and then you'd like count up from blue, and then it would turn green. And okay, like, because the value we get from the measurements are 16-bit values. So we could just use those and use them like their color values, I guess. You know? So we really could just do this same loop. And do this same thing. And then do this. And then do this. Still don't know why that weird flicker is happening. I don't actually understand what's going on there. What do you think of this? Except that's a signed 16-bit value, and it's supposed to be unsigned. But let's just ignore that, and maybe it'll get mad at us. A traffic light. I'm not working with a traffic light. Does it look like a traffic light? Okay, now we have the weird value here. So we're kind of doing the thing, right? I don't actually understand why that's so flickery. Like, why would that be so flickery? Do I need to jiggle cables? Is it because we're drawing over the top of the same thing so much? But it was doing it before. So we need to now think about this for a second. So this is going to be oops. Times X. It's going to be this times Y. Something like that. Don't know why Fusion just opened, but thanks. Thanks, Fusion. Whoa, what just happened? That was weird. The printer just went crazy. That was unnerving. I think this print is doomed. I think that print is not gonna be a thing. Okay, we clearly have issues. I wonder what our issues are. What did we not bring over? Man, that's a bummer. That caused it to pop up. That like ruined the print just now. After almost 2 hours. Bummer, man. Yeah, it's ruined. It's ruined. Ruined. That sucks. That print was looking really good, and then suddenly it was not. It was suddenly not looking really good. I mean, and I probably really only bought an hour by some of the settings I changed, so I should not have messed with it. Also, I should bump off another I should bump off some more millimeters. It is a print for a friend of mine has a fabrication shop, and they got a job to build some fancy furniture fixtures that have some pretty crazy details. And they are building the frame out of wood, which was all CNC routed, and I think that part's fine. But they want these like very fancy casted concrete inserts. And so they're making molds for them, and they have one mold negative that they made, but it will it's like a 24-hour cure time. So they need to make more molds, but they need more negatives or like originals basically to make the molds from. And so that is what this print was gonna be before it was destroyed. But let's just do it. So the print was going okay. I think it would have been okay, but once the corners popped, it just meant that everything would have not been level anymore. And, you know, it's like, it needs to be pretty accurate. If I could get it to be like 12 hours. Okay, well let's have a fun diversion. So this was my like cutting off. So I think we can cut off a little more. Really the height. Okay, we want to cancel that. Edit this sketch. I did not do this the way that I should have done this. In fact, let's just redo this because I feel like I should not have done it this way. We actually should have drawn the perimeter and then set the height that we wanted. So let's delete this. And maybe that just broke the file. Probably broke the file. Yes, I absolutely want to see your high-tech Wi-Fi antenna mount. Obviously, of course I do. Well, so you can, I mean, like, I did that thing where you use the crazy, that crazy casting material that grows, and you can grow things, but then you have to like do it and then cast that and use the growing material and then make a new mold from that. And like the whole point is to cut down on the number of mold iterations by using like these 3D printed negatives, which are fine. Like the result is good. They're just slow. And so the aim was to make just see if I could speed up their 3D print, because that was actually the problem. Because the 3D print that they ended up with that they're working from is good. It's very good. It's just slow. So let's do it with a center rectangle. That's 200 millimeters. Why does that seem so big? Why does that number seem outrageously huge? What have I done? What? What? What did I do? What did I do? Very classy. Very nice. Very good look. Did I just do something? I don't understand. I don't really understand what I did. Okay, let's try this again. We want to create a sketch on just this plane. And we want to center a rectangle. Nope. Center rectangle. Just 200. Oh, I probably accidentally typed 200 meters. That's probably what I did. Okay, so now we can finish this and we can extrude it. So I had done 200 before. No, I hadn't. I'd done 50 before. That was too much. It was too much. It was too much. Stop. Really doing well with... Wait, what is... I get 2 links? What's the second link? This should only be 50 millimeters. Okay, so here's the trick though, because we can go further than that, right? We don't really need any of this. So say it was 55 millimeters. Is that too close? I think we just do it. Probably really thin there. It's only a millimeter or two, but I think that's good because then I can know very quickly if it's going to fail disastrously. I don't know, man. Maybe. Let's try it. And then let's try not to be too fancy this time. So, save it as a mesh. Okay. Oh, did I mess up the coordinates? But the weird blinking doesn't... It still seems not right. But, okay. I believe you that I messed up the coordinates, but it still seems unstable in a weird way. Okay, go to the slicer. I mean, the numbers that this gives you are all made up anyway. So if we just slice this as is, this was with my weirdo settings. So let's try standard quality, discard my weird settings. So if we just printed this like a normal human would print something, it would be 17 hours. If we didn't print the bottom, it would be 14 hours. If we did this adaptive layer experimental thing, it would be 15 hours. So that actually took it up. If we went down to 10% infill, this is what worries me though. So let's try this, and I guess let's try adhesion. $11 hours. Well, but the small scale, like, it doesn't... I don't think the small scale will, like a smaller scale won't help me in this because I know the form is right. So it's not like, you know, if I was trying to figure out if the form was right, it might be useful to do a small scale and type. This is just about trying to get the print done. Now, maybe I should have done a small scale to try my weird infill settings, but my weird infill settings, I think, actually worked. I just don't think they saved enough time to really justify themselves. But I can live with a I think I can live with 11 hours. I mean, it's such a made-up number. It could easily take way more than that, but let's try this, and also I'll know relatively quickly if it's just a disaster. I mean, maybe the 10% infill. I mean, maybe the. I feel like 10% infill should be okay with this. But I had messed with like weird speeds on the other one, and yeah. Okay. Let's try it. And I did a wait. I thought I did a skirt. Where's my skirt? Oh, can I not? Wait. I just didn't preview. Okay, there's my beautiful skirt. Okay. Let's try it. Let's try it. Okay, okay. What were we doing? Okay, Binary accused me of bad programming, which is a very serious accusation. Okay, I know this looks wrong, but it actually is correct. Width is just the like side length, and because it's a square, it is the same. Kind of doesn't seem right though, right? Like. I am? Oh! 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 Oops. Yeah, you're right. I did it totally wrong. It should be this, and then this. Okay, I did do it completely wrong. You are right. And then these should just be. Okay, I have to say, Binary's accusations, while shocking and upsetting, were actually correct. They were correct. How about that? Yeah. Is that better? Maybe that's better. Maybe that's also terrible. It's less wrong. I don't understand why it's so slow. Like, why would it be so slow to just draw this? This is just a struct, right? And we populated it up here. Whoa. Okay. So what is this insane scanline thing we have going? Whoa. Wait, sorry? Oh, well, you're right. I don't actually have to clear this, right? Because I'm just drawing over the top of it every single time. Is that what you mean? Skip that? Because I'm always filling the screen entirely, so I don't actually have to do that. But that still doesn't quite explain the weird, like the scan line thing, right? Like, what is the... Well, it's just in this loop. This is just like the you know, the Arduino loop. But maybe it's just really slow. And we don't have to do it. We don't have to do it. So, okay. So the problem here is like these colors are basically meaningless, right? And they're still very scanliney, which I don't understand. Is there something about these fill? Is this like? I feel like I'm missing something. Yeah, I mean, I'm drawing. I'm filling the whole screen with what I'm drawing, so I don't have to clear it. That is totally true and totally fine. But it still feels weird. It just feels wrong. It feels like it's. It feels like it's scan lining. Like it almost feels like it's trying to, like it's async when I don't really want it to be asynchronous. Like I kind of want it to block, right? I think. Read diagnostics, but it can help debug problems. Well, let's try this, actually. Just while we're at it, let's get these diagnostics. Oh, but we can't because we're outputting our own stuff. I mean, we can, but... But doesn't this just seem really weirdly suspiciously slow? Like I just am forgetting to do something? Like, what's with these yields? Is that weird? Like all this stuff where we're yielding. Just out of curiosity's sake. Or for curiosity's sake. What? I mean, again, we could look up how it works, but why would we do that? So flickery. Well, that seems to not make it. That seemed to make it angry. That seemed to make it so mad. Let's try to upload again. Doodaloo. Oh, I see. You can do this color 565. Why does it seem so slow? Okay. Great. Love it. It's beautiful. Rounded rectangles, triangles, all my favorite shapes. Mm-hmm. Oh, like that's the measurement data. I mean, that's just the. You think that is the slowness? I think that's just a struct. So I don't think that's the slowness, but I see. I get you. So, right, sure. This could just be whatever. And then we'll try to comment out the whole sensor block and just see if it's something weird about slow sensorness. We were uploading so fast yesterday, and today, not so much. I don't know why. I don't know who to blame. Teensy? Like, even when it drew that, it drew it in a very scanline-y kind of way, right? This is gonna like overflow in some very exciting way, right? Okay. Well, let's try it where we're just drawing and not trying to talk to the sensor. It's still like it's still scanning, right? Like it's still like you can see the sweep. So it feels like there's something about the way it draws. Something about the way it draws is a little suspicious. Well, let's go to the yield in here, because that was a guess anyway. Also, the insane flicker. Okay, is just records. We're still just drawing the. I didn't notice it in the demos either. Let's try to run the demo again and see if we see what looks like it's sweepiness. So that's why I'm wondering if I just missed something. Right? Like if I just missed, because I just copied and pasted. Like maybe there's something about the initialization that I just missed. But let's run this graphics demo again, because I didn't notice. Sweepiness. But maybe it was sweepy right before my very eyes. What? What happened? Oh, we lost our custom. I didn't save the custom changes. Lame. I don't remember what they were. Oh wait, they're over here, aren't they? Okay, well, now we know those were needed, so great. That's not where miso is. Oops. I messed up. It is sweeping. When it clears, like the fills are sweeping. Those don't seem like they sweep. But the fills do. But why would drawing subsequent squares? Are you doing something weird in here? Like all we're doing is looping 64 times and trying to draw a rectangle, right? We're not doing anything weird. I just did that so it doesn't end up black when y or x are 0. Yeah, it don't look like we're doing anything weird. Was it sweet? It looks extra sweepy now in a way that I don't remember being sweepy before. Like even those demos were sweepy, and I didn't. Maybe I just wasn't looking for it. There's something we need to know about this thing. Oh, draw from bottom to top. I think you're right. I mean, I think it will, but I see what you mean. So just invert this basically. Because all the demos seem to sweep in the same way. I don't know what that means. Doop-diddle-doo. 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 Wait, it is sweeping the other way. It feels like it's async, right? Like it feels like it's trying to asynchronously draw these because it's so slow. That would be weird. I mean, I don't think that's what's happening. It's just kind of what it feels like. Wait, where is the documentation? This is 18-bit color. We only had 16. $18-bit. What? So where's the actual documentation for this? We were looking at it before. How did we lose this? It's this. Okay. Right? I mean, I guess we could just see what other... Just can't find the documentation for the thing. So... Mandelbrot, on off, picture in red, touch paint. Mandelbrot. I mean, this is not very helpful. Just want the documentation for it. Where's the documentation for the library itself? Hmm. What does that mean? The begin method. Flip X and Y. I don't think it will. I think it'll go sideways. I think it's like kind of asynchronously drawing them. I don't think it's scan lines. I think it's like a drawing thing, even though it seems like they should all happen in one. Yeah. It just is slow. It's just slow to do. So, okay. It makes sense to me now. It's slow. You're still in a single loop, so it's not like an async thing. It's just literally very slow. And so, oh, I see. Oh, sorry. Yeah. It's just astoundingly slow, I guess. This is what we. I mean, it's a lot of pixels to send, I guess. I don't know how much it sends when you draw. Like if it has some graphics buffer that it's trying to update or something. I don't know. So I guess it kind of makes sense that it would be. It's only sweeping because we wrote a loop, right? So like we could, if we went from the middle or whatever. So YouTube people doing smooth stuff. Well, I wonder if there's a buffer. If you could draw to a buffer and then send a buffer. So in other words, like if you could compose your own full screen and send that full screen, but I assume that's less efficient than what they're doing. Also, that would be kind of annoying. I mean, maybe there's something. Yeah, like if I could draw to a frame buffer and then draw the whole buffer at once, it still might be kind of slow, but I don't know. How are these YouTube people doing smooth stuff? How do they do it? Yeah, frame buffer would be the way to do that, I guess. Get an internal. So, but like, how could you? So draw a fast raw V line. So I could draw fast lines. I guess this is the canvas. So I mean, I don't know this, but I would kind of presume that I could set. That's a 1-bit canvas. Well, this is kind of weird because, like, does this just mean you can do whatever you want to the buffer? Like, if you... Can I just mess with the buffer? What are these actually? Start a display writing routine. What do you think that does? Nobody knows. And start right seems promising, right? Where is the write a pixel? What? Overriding subclasses of start rate is defined. Draw fast. So, where are these things? So, like, if we were gonna do a fill rect, it just loops through and draws fast V lines. Interesting. Draw grayscale bitmap. Draw an X bitmap. And like draw a bitmap. So you could like construct a. What's 1 bit though? These are like 1 bit images. (16-bit image). That's an RGB bitmap. Of course he did. Of course he did. Is there a custom library? Paul, but this is the this is not the display I have. This is the one Life is Yours has. Yeah, I'm sure it's a billion times faster. Right? Teensy3 native optimized version. That's what we're using. This is using Adafruit. I mean, it's using Adafruit library. So I wonder what the optimized trick is. Is it the optimized SPI library? Oh, no, it's so many pixels. But I mean, I don't know. There's got to be a fast way. I'm sure Paul has a fast way. Because he had some fast SPI, right? He had like some faster SPI library. SPI for Teensy3. Oh, we could overclock it, but I guess I don't know what the slow part is, you know, like. Oops. Yeah, but we have a oh wait. The IL, this is it. So Paul does have a optimized. It's my exact stupid thing. Paul's always a step ahead of me. It can be used with this. Okay. or the optimize library. So how do you, can you still use this with graphics? This is really old. Highly optimized. This is very old. Yeah, I'm not drawing the whole screen. This is just like, because the way it draws rectangles, it just draws a bunch of lines to draw a single rectangle. So this isn't even in the main loop. This is just as fast as you can draw rectangles with this, I think. I mean, you know. Whoa. So that was the Arduino Uno. And that is 2.5 million. And this is 280,000 microseconds. So an order of magnitude improvement. But it's old. Hasn't been, well, this was updated 17 months ago, so maybe it's not that old. So what do I actually need, though? Can I just... Like, I'm a bit confused. Some cool gradients. I mean, I could, but that would be real slow. I mean, so one, there's not a straightforward way to do that. Like I was looking at that of how do I draw all the pixels all at once. I could draw them all one at a time, a pixel at a time, but I don't think that would be very fast. So certainly I have much more faith in Paul's abilities here. So, but I'm a little confused. So this just straight up has everything. This just has the stuff. But do you also need the... It doesn't seem like it. Seems like this both talks to... Okay, let's just try this. Because why not? Oh, well, is this going to be annoying? Yeah, but I mean, we're totally isolated in our own little weird land anyway, so I don't think it matters. But if we don't use Visual Teensy, then we won't have everything properly added. We could do it manually. We just have to manually edit the makefile and whatnot. Well, look at this, right here, right before my very eyes. So we could. So are you telling me I can trash this and trash this? Should I use the fast SPI instead of the not fast SPI, or is this just the fast SPI because it's the teensy one? Is that what this is? I don't know. Okay, let's try this. Save it. So presumably that, oh, it didn't. Why didn't it get rid of these? Well, we got great news. It says it's only 93 hours, so I don't know. I don't know what to think about that print. I don't know if I should like try to optimize it more. It just seems like it's too easy to break things. So the graphics test, this graphics test does what? I mean, I guess we don't have to do this whole thing because we just assume. So we don't need these. We do need this. We don't need these. We do need this. Feels like it probably messed something up, right? Wait. Am I crazy? Didn't I just... I thought I deleted this. So we do need this. Did it work? It would appear it did not work. We have this thing. We have this. That's for the other stuff. That's all commented out right now. We created this. DC and CS. Didn't really tell us what other pins to use though, did it? Because we had to fully specify that with the other library, right? There's something different about... Those are draw rects. What did I forget? Uh-oh. You? Was it you? So I definitely broke it, but how did I break it? I don't think so. There was just the begin. I mean, the biggest thing was just the parameters to the I don't think so. But these parameters, I had to use the longer form. You seeing a nit? The example didn't even have it. Demo sauce. Greets. 13, 12, and 11. Use hardware SPI, 13, 12, and 11. I did. Didn't even use reset. Well, does this have that longer form initialization? It does. Okay. Reset equals 255. Okay. But is this not what we set things to? So our cable select, and we're 9 for DC, 10 for cable select. Oh man. I think the signature is just the same. I don't know what we're doing differently. Maybe that'll make everybody happy. I don't know. Doodaloo. Doodaloo. Where's the doo-doo-doo-doo? We didn't get a doo-doo-doo-doo? Oh, yeah, I don't know. Well, these don't. I haven't seen any with this this device take a size. I was hoping this would magically fix it. Did I get this order correct? This order is not correct. Wait, come back. This order is different. This order is CS, DC, then reset, then MOSI. Then clock, then MISO. And CS is 9, and then 10. Reset, we set to 8. MOSI 11, MOSI 11. Clock. I had an S clock. Clock 13, MISO 12, MISO 12. So I don't know. I don't know. Doop-de-doo. Where's the doop-de-doos? Whoa, look how fast it is. Look how fast it is. Why would I ever even... I mean, obviously, I should just use Paul's thing. Because obviously, Paul's thing is always better. Always better. I switched to using the... I switched to using the rewritten library by Paul Stoffagen, which is optimized for the Teensy. He's the designer of the Teensy, and everything he writes is insanely fast and optimized. So basically, Adafruit will write something and it'll be slow, and then he'll be like, I can do better, and then he'll make it better, and it will run like stunningly fast, like just shockingly faster. Okay, so now what are we doing? We want this now, and we want the measurement here. We still have our color problem. That is not a resolved problem, but I just switched to Paul's library. That's all it takes. It's always the right answer. He wrote the encoder library. Just use his encoder library. Like his benchmarks from that form were an order of magnitude faster. If I had realized he had written a library, I would have used it because he's really good at his job. He's extremely good at his job. Why isn't everything like that? It is if you just use his libraries. Okay, we still have the color problem, and I don't really know what to do about the color problem. And actually, maybe I do know what to do because I think this library had some extra color stuff. This is the 8x8 laser array. So this is just a very low resolution depth image, basically. But it's pretty dang accurate. Like the lighter colors are further away. There's me. It's just I was using hue before, so that should still work, right? We should still be able to run the yeah. So this is a little easier to tell what's going on. Also, somehow our X and Y... Oh yeah, we flipped all the variables. I forgot. Let's unflip our variables. But on the processing side, we were just kind of cheating. I know, seriously. Hasn't everyone been paying attention? Like, watching with bated breath for me struggling for 2 hours and 45 minutes to make this stupid screen work? I don't understand why. How could anybody have missed a second of this riveting content? How come... shouldn't this be correct now? It still seems like my X's are backwards. Maybe the screen... Oh boy. Maybe the screen is... coordinates are backwards? Oh yeah, because it's Y. Oof. Okay, this is a little confusing to try to figure out. Where even am I? Okay, so that must be the Y. Oh, that's weird. It feels like I'm fully rotated. And my screen is flickering again. This tiny little fellow is the laser array. So this whole board snaps in half if you want to just use the tiny little laser part, which I don't know, maybe I'll do that. That'd be a silly thing to do. The pin spacing isn't quite right. It's not like I could just solder pins to it. I would have to make a weird little wire harness, I guess. But it is quite cute. Can't argue with that. So I'm the blue blob back there over my shoulder. We can't really see. That's the ceiling. I kind of like it. I can't really tell what's going on, but I kind of like it. My x-axis seems backwards on the screen relative to what I'm outputting. Is there a reason that would be true? We're flipping x here. Yeah, I don't know. That was a weird one. I don't quite understand why I'm flipped on the x-axis. I mean, I think the y-axis is right. I guess I don't really know. It's kind of hard to tell what's actually going on. But if I'm a human and I'm back here, it feels like it's not working as well as yesterday. Did I break something? Oh, there's a wire in front of it. One of the jumper wires was in front of it. That's cute. Okay. That seems a bit better. But that still doesn't seem right. Oh, this is the proper orientation. I think. It must be this. This way? Is this the proper orientation? I think so. That looks right, right? Well, so the coordinate system of the sensor is like weirdly inverted and backwards. It's like inside out. It's both upside down and backwards. And I actually am not totally sure of what... I think this is the proper physical orientation of the sensor. And so I think the flipping that I'm doing on the Arduino is correct. I mean, on the Teensy and then sending to processing, I think what we're seeing in processing is actually right. I think what I'm seeing on the TFT display is rotated. Or I could like turn the TFT display to be tall, and then it would be fine, but the X would still be flipped. So like kind of no matter what, the X is flipped. Because I think this TFT display is actually meant to be oriented vertically, I think. I mean, assuming it takes X and Y coordinates. The width of the square is just the width divided by... I mean, what does it say the width actually is? Does it say it? Long side first or short side first? Yeah, it lists it as 240 by 320, so I think it actually is supposed to be mounted vertically, but the X is still backwards. So actually, I mean, think basically down here. So the inside out X from the that comes from the sensor board, I think is actually what the is actually what the screen wants. So I think if I do this, then the screen will kind of be right, but it'll be rotated sideways just because I have it mounted on the thing sideways. Yeah, so once that's true. So once I have it drawing in the right direction, I can just rotate the screen orientation. So we spent 3 hours doing this. Why? Why? Why did we do that? Things are not going well back here. Should I just let it go? Do I just let it go, or should I fuss with it some more? So the infill is really a problem, I think. I don't know which one's the more recent one. This one is the latest one. And so that was at 11 hours 56, which is a lie. But at 20% infill, that's 3 hours, but it may just have to. Because it really looks like a mess. The previous print is once you get to this spot, so you're kind of building this cage, right? Like the infill cage in here, this honeycomb. When I had it here at 10%, which is what the previous person who had printed the original model printed at 10%, it has to like span filament all the way across these big gaps like this, and it's kind of like sagging into those nooks and crannies. And so just using like the standardest of standard settings and except adding support and then slicing, oof. If we go low quality, right, standard, discard, go to low, oops, low quality, slice. That was 50. Wait, what? Oh, 17 here, right? So it cut off like 2 hours to go to low quality, but we do want adhesion. $17 hours. We could try a gradual infill. That seems like it's going to be terrible. That was terrible. We could do low quality, adhesion, 20% infill, and then not do the bottom. So that's 15 hours. Is that going to be too low quality? And if we just like didn't print the bottom because we don't care. That's not terrible. Okay, what about this? Standard quality. Don't mess with anything. It's going to be 17 hours. Right? We don't care about the bottom. $14. Man, I was really hoping to do this. I potentially could, but the gaps are inside the cone part. So even if that would probably take longer to print them individually. I mean, or do I just let it go? I'm an hour in on this. At 10% infill. It's not the worst, but there are some issues. I mean, I could also, maybe there's like a better infill method. Oh, look at that. Would that be better? Like, look at the resolution of this. What about zigzag at 10%? Yeah, it's just I'm getting like some weird bubblies that have me worried. Like this almost looks like the density of the 20% infill right now. It's just faster. Like this was crazy. This was 4% infill, and that was not the way to do it. This was 10%, which was going okay until it got to like, it just started to really chunk out in a place that seemed bad, because if this stuff becomes a nightmare, you know, everything kind of builds on top of this. So if this is not going well, it's not going well. Now I can't even remember what I changed between this one and this one. Like on the current one, there's just some places that have sort of collapsed inward. This looks denser than this. Even though this is only 20% infill, it's just a different pattern. So I was doing cubic. Which is not very dense. So if instead I did zigzag, it looks denser. What does a grid look like? Bad. Grid looks not very good. 20% infill. I don't know why. I don't really understand why the zigzag ends up being so much less. Oh, does it literally just go straight up? Maybe that's fine for this though. I see. It really is just straight up. But maybe that's okay. I feel like the print I have is going to go south. Yeah, I'm going to stop it. Man. So the like foundation was fine, but it started to get into the same issue here where it just wasn't spanning these gaps. They're just too much. And somehow weirdly the grid infill, even though it doesn't look like it would be more supportive. I think for this very particular model, it might be the jam. I mean, especially this like super dense grid infill like this. Maybe there's a better, let's just take a tour of the infills. So we saw grid. Lines looks a lot like zigzag. I don't think I really understood the difference. I'm gonna be careful. I'm gonna run out of filament for this done. So triangles is no. Trihexagon. Cubic was a no. Maybe cubic subdivision. That looks insane, but seems awful for what we're trying to do, because it's like this. It's like you're trying to run filament right across this, and it just wants to fall into the hole. So far zigzag seems good. You do get some weird, beautiful things. Look at this. That one's interesting, but you end up with those giant negative spaces. Like, just don't. For this particular model, those are just terrible. Not good. I don't think that's interesting. Huh. Yeah, I guess it's a good question. Like, is zigzag actually... Oh, it's like cross-hatched. Oh, that might be terrible. Or it might be great. I mean, if zigzag is doing its job and we're like able to confidently... Interesting. Okay, that's why. The problem is like, what is keeping this filament from just sagging into this little valley? Got it. So we thought that lines looked like zigzag. Is that doing the same thing? Yeah. I don't think I understand the difference between lines and zigzag. Okay. Well, that would explain that. Maybe zigzag is horrible for this, because maybe it would just sag as we're trying to build up. Oops. Shoot. Come back. Did I accidentally move the model? The cross is cool. It doesn't seem good. It talks about the infill, like, high level, but not about the individual. So yeah, line and zigzag infill swap direction on alternate layers, reducing material cost. Grid, triangle, trihexagon, etc., 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 are fully printed every layer. Change with every layer to provide more equal distribution of strength over each direction. But that's about like object strength, I think, and not so much about the thing we want, which is like a substrate for these long Whoa, look at that. Is that good or is that terrible? Kind of love it. It's still a longer, these are still longer gaps than zigzag. So cubic, I believe, is kind of the default. And it was very solid. So zigzag, maybe zigzag is good or maybe zigzag is terrible. Well, I don't think you can. So it has like the vase mode where it basically only prints the skeleton. But I have to have a fill because some of these, once you're going up in the cone, like you could try, I guess, to just always be drawing like on the edge of the wall, but that's what was melting inside. Like not having the, not having some like cross substrate support is what was causing it to kind of weirdly melt inside. I think when it had this to span these longer areas, it just wasn't sticking. Print it upside down. Print it upside down. I would have to print it with support. Like I'd have to print supports on the inside because these would not survive. The printer would just knock them over. I like the idea of it. I don't think it'll actually work, but I do like the idea of it. So I am kind of feeling zigzag, I must say. So even at 20% infill with zigzag, it's 14 hours. And yes, you have the little material sag in between, but it's so small, it may not matter. I keep moving the model, which is bad. I should probably resend this from Fusion just to make sure I didn't accidentally screw something up. The sagging one was on cubic. All three that I've done have been on cubic, but with just like various other settings of speed and infill and so on. So the zigzag. So I'm kind of into the zigzag. Because if I was nuts, and this just might be a terrible idea, I could speed up the infill speed. Like I could do the like basically draw the infill faster. Like draw the infill at 70 because there's just a bunch of straight lines, and then that would let me draw this at say 50. I just don't know if it's worth it, you know, like to push the printer. Doesn't really gain me that much, but it could compromise the print. I'm also a little worried. Okay, I do want to just send this from Fusion again, just to be sure I didn't mess something up. I just want to start a print and go to bed and wake up and have it be beautiful. Is that so much to ask? Okay, so again, if we just were regular old standard quality, like a bunch of bums, is like 17 hours. We absolutely do not care about bottom layers at all. So that gets us to what, like 14, 15? That's 14 hours cubic. And if we don't touch anything else and just go cubic to zigzag, even still at 20% infill, there's not a dramatic change. But I still think it's better. I still think it might be better. Like, the density of this, I mean, maybe it's not. Maybe I should just print it at 20% because I've been printing it at 10. I mean, maybe I should just print it at basically all stock settings. All stock settings except for that bottom layer. I don't know. What's the vote? Jacqueline, I'm so pleased you stopped by. Missed you. Have a lovely night. I really appreciate it. What are we doing, everybody? I just, it takes an hour to do an experiment and I'm gonna go to bed. So I think I'm just gonna like do this pretty conservative thing, but also add support, which is gonna add time, right? Oh, sorry, not support. No support. I meant to add adhesion, not support. Let's just do it. Let's just do it. What could possibly go wrong? I mean, a lot of things. A lot of things could go wrong. Save to removable drive. This is the one. I can feel it. It might also just not be the one. I just don't normally print things this big and this long and this funny shaped. So it could also just be that my printer is just not well calibrated for this particular endeavor. Okay, this is the one. This is it. I've got all these nice speaker grills now. I kind of like them. I mean, I could use that as some kind of thing. Looks pretty sturdy. Took like an hour. Could definitely cut down on some settings to make it a little simpler. Okay, people. We made the thing, right? Although suddenly it's not working. What happened? What happened? Wasn't this working? I just jiggled the wires and it's working, so. Strong vote of confidence. So I guess the thing we have to do is, oh yeah, good idea. I can just print my home. Smart, very smart. Okay, yeah, I don't know. Now we have this thing. So for whatever that's worth, the lack of, that's what we were gonna look at before I got so rudely awakened, is the additional color methods. Because I thought I saw some other color stuff. Is that not true? Oh yeah, this stuff. (14-bit) RGB. I don't understand. What are any of these formats? Those don't really seem like they're anything that I want. Yeah, the color stuff's just kind of lame. Yeah, what do you do? What do you do? You just like truncate those color values? I don't exactly know what to do to get the thing that I want, which was that RGB wheel, which, oh, excuse me, hue saturation value or hue saturation brightness or hue saturation lightness, whichever one, to RGB is not crazy difficult, but it's a little weird when you suddenly lose some bits. I don't know. Gotta think about that. I don't really know what to do with it. I guess we could just do it grayscale, basically, right? Just put the same value. But that's even weird. We can't put the same value because they're different. How high can we count? Like, what is our actual color range? It's 5 bits, right? And then an extra bit for green, but if we just ignored that. That's not great. That's basically 32 values per channel. I guess if you did in green, you could count to 64. But that's really... Is that weird? Does that seem insane? Or is there some good... There's not a lot of resolution there. And if you just stack them on top of each other, it gets pretty weird. Because if you're just stacking them, you're not really getting all the full resolution. You're just kind of getting, or you know, you're not getting the full range of possibilities. You're not really getting, you know, like a full 65, 535 range of colors. We can't count that high anyway, though. That's why we're not getting to red in this. It's because we're a couple powers of 2 off. You just multiply it times 16, like whatever the measurement is, because we know it goes to 4,000. Is that weird? There must be something wrong with my thinking there. We'll just try it and that'll be the last thing. Yeah, it's just gibberish. So we should just draw. We shouldn't do it with color. We should do it with scale. That's what I meant. I just try to use it. Just try to use every bit, but then it's not linear, right? Right? It's not going to be. It won't seem linear. So I'm using all the values, but it just seems like chaos. Of course. I'm sorry, this Swift UI sucks. So the thing to do, I guess, is just like draw it white, but or draw circles or something and just do it with scale. It's not as good. Okay, I'm done for real. Garage 2.0, Binary, Life is Yours, Draklin, The Prodigal Son. Thanks for hanging out. And maybe we'll talk tomorrow or maybe not. I don't know. Maybe a couple days. Gotta make this. I gotta make this print happen. Okay, goodbye.